So for 11.3, we're going to talk about the converse of all of the theorems that we talked about yesterday. So converse, remember, means that you flip the conclusion and the hypothesis. It's not always true. In terms of the angle theorems that we talked about yesterday, the converse is always true. So that makes it a biconditional. Okay, so basically it means that, for example, hold on one sec. For example, theorem 9 is the converse of the corresponding angles. So it says that if you have two lines in a transversal and the corresponding angles are congruent, so I'm telling you for sure those are congruent, then you may assume that the two lines are parallel. So if I give you an image that looks like this, and I tell you that angles 2 and angle 6 are congruent, we can say that line L is parallel to line M. Does that make sense? So if it's not given that the lines are parallel, but it's given that the corresponding angles are congruent, you may assume that the lines are parallel. Same thing is true for the alternate interior angles theorem. If two lines in a transversal form alternate interior angles that are congruent, then the two lines are parallel. So in this image, we can assume that line L is parallel to line M. Basically, that's going to be our assumption for all of these. Same side interior angles postulate is the same thing. So if two lines and a transversal form same side interior angles that are supplementary, then the two lines are parallel. So then same thing, you can assume that L is parallel to M. And then last one, converse of the alternate exterior angles. So if you have alternate exterior angles and they're congruent, then the lines are parallel. So same thing, L would be parallel to M. So what you are going to do, and basically that's it for the theorems that you're going to talk about in this lesson. So what you're going to do in your packet, problems 1 and 2, wants you to use those to explain why certain things can be parallel. So let's go over this one together, but then I'm going to have you answer it in your own words. So number 1 says that the fence gate is made up of pieces of wood that are arranged in various directions. Suppose angle 1 is congruent to angle 2. So here's angle 1 and here's angle 2. So suppose they are congruent. Can you assume that lines R and line S are parallel? So can we assume that this line is parallel to this line? Here's your transversal. What do you guys think? Which theorem did you use? Converse of the alternate exterior angle theorem. So these form alternate exterior angles. So in your answer, this is kind of how we're going to practice. You know, for the performance task, you had to answer in complete sentences, and we're going to practice that. So, yes. What are we saying yes to? R and S are parallel. So you can say R and S are parallel. Well, let's explain it a little bit more. How do we know these? We could say that angle 1 and angle 2 are alternate exterior angles, right? So we can say angle 1 and angle 2 are alternate exterior angles. That are congruent. And then I want you to explain the theorem. So we're going to name the theorem and then explain what it says. By the converse of the alternate exterior angles theorem, I'm just abbreviating, by the converse of the alternate exterior angles theorem, comma, if two alternate exterior angles are congruent, then the two lines are parallel. I fit it. Okay? So in a question like this where it just says explain, you first want to answer the question. Then you want to explain why. And then you want to name the theorem and the words in the theorem that explain why. Okay? If it says, this is a short paragraph, it was 3 sentences. You can do it. Yeah, Kevin.
If it asks us a question like this on the homework, do you want to write it like that?
Yep. On the homework, I want you to write it like that. So, do number 2 for me on the other side. Okay, so you guys, for number 2, 2 workers paint lines for angled parking spaces. 1 worker paints a line so that the measure of angle 1 is 65. And the other worker paints a line so that the measure of angle 2 is 65. So these are congruent. Are the lines parallel? Explain. First of all, are the lines parallel? Yes. Why? What types of angles do 1 and 2 form, Jen? Alternate exterior angles. And which theorem did you use to prove that the 2 lines are parallel? The converse of the alternate exterior angle theorem. Make sense? That's really all you have to do. So, what I want you guys to do, we're going to do some problems with this. I'll help you set up the first one, and then I'm going to have you do the rest on your own, and then I'm going to use your work to compare with the class. So, number 3. I want to know for which value of x would line A be parallel to line B. So that means that I want to find what value of x will make those angles follow one of the converse theorems to prove that A is parallel to B. So what type of angles do the 2 that are given here form? They are same side interior, which are what? Supplementary. So that means you want to take 2x plus 9, add 111, and you should get 180. 9 plus 111 gives you 120 equals 180. Subtract 120. So 2x equals 60, and then last, divide by 2, so x equals 30. That's all you have to do. Oops. Yep, that's it. So here we go. 4, 5, and 6. Oops. That was weird.
Wow.
I know. So let's look at number 4. What she did, she took 3w minus 2 and set it equal to 55. Why would she set it equal to 55? Because they're congruent, because they're what types of angles? Corresponding, and corresponding angles are congruent. So then solving, you should have got w equals 19. Thumbs up if you agree. Thumbs down if you disagree. I hope everyone agrees with this one. Good. Number 5, we're looking at x, and we want to prove that M is parallel to L. And whose was this? Karina's? No, Lynette's. What Lynette did, she set 3x minus 33 equal to 2x plus 26. Why would she set them equal? They're congruent because they are alternate exterior. And alternate exterior are congruent. Number 6. This one was tricky because there's a distractor line in there. That line in the middle doesn't mean anything for this problem. Okay? Yeah, it had nothing to do with the problem. It wants to know where will line L be parallel to line M. And here's your transversal. So, here's what Tyson did. He took 3x minus 18 and added it to 105 and set them equal to 180. So he's saying that those angles are supplementary. Something that I did here, let me fix this. Something that I did on mine, because technically this is an interior angle and this is an exterior angle. So those, we don't really have a theorem for that. But we could take 3x minus 18, and what other angle could we say is congruent to 3x minus 18? Well, you can't use... Well, this one, right? Can't we say that this is 3x minus 18? Why can we do that? They're corresponding, right? Does everybody see that? I know that this is what he did. He just didn't write it on there.
Or you could have did the reverse.
Or you could have done... You could have done it right here, too. You could have written that that one is 3x minus 18. And now we have a linear pair, right? So that's why they are supplementary. So he got x equals 31, which is what I got as well. Yes?
On our test, do you want to work like that, or can we find the angle at, like, how, like...
Okay, so that is lesson 3. Using the converse of the theorems to prove that lines are parallel. Not too bad?